Okay, in our last video we talked about estimating the regression equation from sample data. So in this video we're going to talk about the least squares method, which explains how we actually estimate the regression equation. So the idea behind it is that we find a line that best fits the data, and we do this by minimizing the sum of squares deviation. What does that mean? Well, if we look at our data, right, this is our data and this is the best fit line. You'll notice that for each observation, right, it deviates from the predicted value, right? That's kind of like error in measurement, but it's a deviation, which is a difference between, right, the observed and the predicted value. It's also called a residual. So what we want to do is we want to find these differences for all of these points, their distance between the observation and the predicted value. We want to find all of those, square those values, and sum them together. And the line that has the smallest sum of these squared values is the line that best fits the data. So if we go back to this sentence now, or expression, should make sense. Minimizing the sum of squares deviations, right? So all of those deviations, we're squaring them, and remember we square them so that when we sum them together, right, because some are above the line, some are below, so some will be plus, some will be minus. We square them so that they don't cancel each other out, right? So we take all the deviations, we square them, and we sum them. So the one with the smallest, the line with the smallest value of the sum of squares deviation, that is the best fit line. This is the methods of the least squares. So to do this, right, here's the expression, right, we're minimizing the sum of square deviations, right, so all the values, the actual observed value and the predicted value, right, the deviations of those, we square them and we add them together. We want to minimize this function, meaning we want to find the value that's the smallest. So to actually do that, we can calculate, we can find the regression equation that has these estimated parameters, right? So we have beta 1 and beta 0, so right, so we got our intercept and our slope. So these are the equations for actually calculating those, and so then once we have these values, right, we have the equation for a line, right, because y equals mx plus b, right, we'd have those values. Then we can just plug in x values that we want to know to be able to estimate or predict y. So let's go ahead and do this in Excel. So here's all the answers, if you will, but let's do them together by hand. So remember, if we want to find the difference between x and x bar is the mean, so the first thing we have to do is calculate the averages for these values. So we're going to do that. So that's the mean for x, and then this is going to be the average for y. So we can find these now. So now this is going to be equals x minus x bar, which is the mean. And remember, this number we don't want to change. This cell, we always want to use that, so we have to use the dollar signs. So we're going to do that, and then we're going to drag and drop. Let me zoom in again just to make sure that you can see what I'm doing. So we have that. So we have these values. Now we want to do that for y. So for our y values, find the difference for each of them between that and the mean. And again, we want that to stay the same, so we use our dollar signs. And then we drag and drop so that we do this for each of the restaurants. Now, the next part of the equation, right, let's go back to our equation. Right, we just found the differences between each of the x values and the mean of x, and then the differences between y and the mean of y. So now the next thing we have to do is multiply those together and then sum them. So this is going to be this times by this, and we're going to do that for all 10 restaurants, and then remember we are going to sum them. So equals sum of that, and we get 2840. Okay, so the next part of this for calculating B1 is we need to find the differences between x and the mean and square that and sum that. So this is going to equal, because we've already calculated this, right? We calculated this up here, so we can just take that value and square it to get these values. And so then the next thing we have to do is sum them, so equals sum, and we get that value. So then in order to calculate the B1 right here, right, we have to take this value we calculated, this sum value of this part, and divide it by the value we just calculated here. So let's go ahead and do that. So to get B1, we divide this divided by this, and what do we get? We get 5, which is our value that we had calculated up here. So we have that first estimate. So the next thing we do to calculate B0, right, B0, right, we can take our mean of y and subtract B1 that we just calculated times by the mean of x. So that's the mean of y, right, minus B1 times by the mean of x. And we get 60. So now we basically have enough for our equation, right? So we have our equation that we can use, that we can then use to plug in values to be able to make predictions. So if we want to actually write out our equation, right, we have that, I wrote that here on the screen, right, we calculated 60 and 5, right? So we have 5, which was the first estimated parameter that we calculated, B1, right, that's our slope, and then B0 is our intercept. So we have y hat, a predicted value of y, is going to equal 60 plus 5x. So what we can do is we can take in a value of x that we want to know a predicted value of y for, and plug it in to be able to get a predicted value. So let me give you an example. What if there are 17,000 students? What would sales be? Remember, we use regression for prediction. So what we can do is we now have 60 and 5, so we can just plug in 17 for x, right? 60 plus 5 times 17 to get 145. So what this would mean is that sales would be $145,000 if there were 17,000 students. So that's how we use regression. That's the process of the least squares. That's how we get beta 0 and beta 1. Those are the estimated parameters which we can use to write an equation, which we can then use to plug in values of x to make predictions about y. So again, as an example, why would we do this? Say we did want to open a pizza parlor, and we said, well, you know, in this one area there's 17,000 students at a local university or school. You know, what would we expect sales to be? Well, they'd be $145,000 worth of sales. I think it was quarterly. So you could then make the decision based off of that information as to whether you'd want to invest and build in a pizza parlor at that location. Something else that I think is worth considering is the actual interpretation of these values. So usually, we'll see this in later videos, this is the parameter that we're actually testing. We're going to use the hypothesis testing to see if this is actually significant or not. Because right now we're doing this estimate, but is this variable, student size, student population size, is it significant? Is it a significant predictor of y? We're actually going to test that. So we test that, and if it is significant, how do we actually interpret what 5 means? What is the slope? Well, the slope, 5, means that an increase in 1 unit of x is associated with an increase, right? It's positive because this value is positive. Sometimes it's negative, but we found that the parameter estimate was 5 as it was a positive value. So an increase in 1 unit of x is associated with an increase in 5 units of y on average. Right, that's an important part. So basically, what do you mean a unit? Well, remember, students was given in thousands, and so was the dollar amounts, the sales. So what we're really saying is that 1 unit of x, so 1 unit was 1,000, so 1,000 students, right, that's what x represents, the student population size. So 1,000 students is associated with an increase in 5,000, right, how many units? 5 units. That was so that's 5 times 1,000. So is associated with an increase in $5,000 worth of sales on average. So that's how you would interpret this parameter estimate, the slope. So the slope, again, if it's significant, you would say that An increase in 1 unit of x is associated with what change in y? A positive change of +5 in y on average. So that's mostly it in terms of the method, the approach, how to estimate those parameters, and how to make predictions using the estimated regression equation. So the next video that we're going to talk about is in terms of this equation that we just estimated. Is it a good fit? Then we have to test for significance of the parameters that we're estimating. So we still got some work to do, but we're making progress.